Welcome everybody, my name is Tsuji, and I will be presenting the patterns of the unit circle. And I apologize beforehand, I'm a little sick, so I may be clearing my throat out throughout the video. So, let's start off with an introduction to radians. So recall that dividing a circle into 360 parts creates the degree measurement. This is an arbitrary measurement, and we may choose other ways to divide a circle. To find another unit, think of the process of drawing a circle. Imagine that you stop before the circle is completed. The portion that you drew is referred to as an arc. This is an arc. An arc may be a portion of a full circle, or more than a full circle, represented by more than one full rotation. The length of the arc around an entire circle is called the circumference of that circle. The circumference of a circle is C equals 2 pi r. If we divide both sides of this equation by r, we create the ratio of the circumference, which is always 2 pi to the radius, regardless of the length of the radius. So the circumference of any circle is 2 pi, which is about 6.28, times the length of the radius. That means that if we took a string as long as the radius and used it to measure consecutive lengths around the circumference, there would be room for 6 full string lengths and a little more than 1/4 of a seventh right here, as shown in the diagram below. 1, 2, 3, 4, 5, 6, and then this little portion right here. So before we get into recognizing patterns in the unit circle, we have to be familiar with the basics. The first being that 1 radian is the measure of the central angle of a circle such that the length of the arc is equal to the radius of the circle. This picture here shows how 1 radian is the measure of the central angle of a circle such that the length of the arc is equal to the radius of the circle. Notice how the radius here is equal to the arc length here. And this is what 1 radian looks like. Another key point that we need to know is that a full revolution of a circle, 360 degrees, equals 2 pi radians. After manipulating the equation, we see that 1 radian equals 180 degrees over pi. Similarly, the formula used to convert between radians and degrees is angle in degrees equals angle in radians times 180 degrees over pi. If we look at an example, what is the value of 135 degrees in radians? Well, we first have to set it up in the form of the angle in degrees equals angle in radians times 180 degrees over pi. Substitute in our given numbers, and we're left to solve for the angle in radians. In order to isolate the angle in radians, we have to multiply each side by the reciprocal of 180 degrees over pi. We get 135 times pi over 180, which can be simplified. And we are left with the angle in radians equal to 3 pi over 4. So what exactly is the unit circle? In short, the unit circle is a circle with a radius of 1. Being so simple, it is a great way to learn and talk about lengths and angles. The center is put on a graph where the x-axis and y-axis cross, so we can get the neat arrangement right here. Because the radius is 1, we can directly measure sine, cosine, and tangent. Okay, so now with that out of the way, first let's get into the first pattern that we should be looking for when approaching unit circles: corresponding cosines. This just basically means that the cosine of any degree or radian when flipped over the x-axis is the same as the cosine of the radian or degree that is in the corresponding position. As you can see from this picture, all the cosine values above the x-axis are the exact same as their counterparts below the x-axis. The cosine values in quadrant 2 are the same as the cosine values in quadrant 3, and the cosine values in quadrant 1 are the same in quadrant 4. For example, if we look at the cosine value of 120 degrees, it's negative 1/2. And if we go across the x-axis to its corresponding position, which is 240 degrees, the cosine value is the same, negative 1/2. Pretty simple. Similarly, another pattern that we should look for is for same signs. This means that the sign of any radian or degree is the same as the sign of the radian or degree when flipped across the y-axis. It's almost the same as the corresponding cosine pattern, except instead of flipping over the x-axis, it's now the y-axis. Here's a picture so that you can visualize it better. If we look at the sine of 150 degrees, it is 1/2, right here. And if we go across the y-axis to 30 degrees, the sine value is 1/2 again. So next, let's get into the same tangent pattern. This pattern just means that the tangent of a radian or degree is the same as the tangent of a radian or degree that is 180 degrees or 1 pi away, which is on the exact opposite end of the unit circle. In this picture, we can see that the tangent of 45 degrees, which, keep in mind, tangent is sine over cosine, is 1, since rad 2 over rad 2 is equivalent to 1. If we go to the opposite end of the circle, or 1 pi or 180 degrees further, we get to 225 degrees, whose sine and cosine values are negative rad 2 over 2 and negative rad 2 over 2. This means that the tangent at 225 degrees is also 1. Again, this pattern works for any degree or radian on the unit circle. Another pretty simple pattern is the opposite side pattern. This just means that the sine or cosine of a radian or degree is the opposite of the sine or cosine of a radian or degree that is 180 degrees or 1 pi away, or on the opposite end of the circle. Like the tangent graph, if we use the sine value at 30 degrees, which is 1/2, and then go about the same process as the same tangent pattern and go 180 degrees further, we end up at 210 degrees. The sine value of 210 degrees is negative 1/2. The negative of its counterpart, 180 degrees back. Remember, this is 1/2, and this is negative 1/2. Similarly, if we take the cosine value at 135 degrees, which is negative rad 2 over 2, and then go 180 degrees further, we end up at 315 degrees, which has a cosine value of rad 2 over 2, the negative of negative rad 2 over 2. Now let's move on to coterminal angles. This is a great pattern that will definitely help when going about the unit circle. Essentially, this pattern means that every 360 degrees, or 2 pi, the sine, cosine, and tangent values are the exact same. Let's look at an example. What is the value of sine 2,385 degrees? You might be thinking to yourself, 2,385 degrees? That's not on the unit circle. But there is a really simple way to calculate the sine value of 2,385 degrees using the coterminal angle pattern. Keep in mind, every 360 degrees, the sine or cosine value is the exact same. Essentially, what we can do is keep subtracting 360 degrees from 2,385 degrees until we get to a value that is on the unit circle. If we subtract 360 once, we end up with 2,025. Not really making a difference. What we're going to have to do is subtract 360 5 more times. And what we're left with is 225 degrees, a degree that is on the unit circle. The sine values of 225 degrees is, if we look at the unit circle, or if we should have memorized, which is right here, is negative rad 2 over 2. Therefore, the sine of 2,385 degrees is also negative rad 2 over 2. So, in case you're less of a visual person and more of an analytical person, here are some of the equations for the patterns that we previously talked about, right here and right here. All of these equations can be used to calculate values one way or another. Lastly, I'd like to leave you guys with some tips when approaching a unit circle. First, any radian value with a denominator of 6 will have a cosine value of plus or minus rad 3 over 2 and a sine value of plus or minus 1/2. Any radian value with a 4 in the denominator will have a cosine value of plus or minus rad 2 over 2 and a sine value of plus or minus rad 2 over 2. Any radian value with a denominator of 3 will have a cosine value of plus or minus 1/2 and a sine value of plus or minus rad 3 over 2. Any radian value with a 2 in the denominator will have a cosine value of 0 and a sine value of plus or minus 1. And lastly, pi radians and 2 pi radians will result in a cosine value of plus or minus 1 and a sine value of 0. These values will always hold true. So I hope you guys learned a lot about recognizing the different patterns of the unit circle in this video. Thank you.